So maybe let's get it started. Thank you all for coming to this presentation entitled Contract Tests in the Enterprise. We have a lot of stuff to talk about, so I'm going to start about talking about myself. So to begin with, my name is Marcin Grzejszczak, and I work for a company called Pivotal. Who has heard of Pivotal? Okay, quite a few people. So for those who don't know what Pivotal is, we're the people behind Spring, Spring Boot, Spring Cloud. And I'm a developer at the Spring Cloud team, and I'm mostly working on those free projects, Sleuth, Contract, and Pipelines. You can find my Twitter handle, it's at @mgrzejszczak, but if it's impossible for you to type it, you can go to my blog, toomuchcoding.com, and find it there. So I'm going to tell you a story. Let us assume that I'm a developer working in a sad company with sad code. Like, my life is miserable, but the beginnings weren't that bad, because we had the greenfield ones, right? So it wasn't the first ever project we worked with. So we had this experience of previously failed projects, and we said, like, to ourselves, we're not gonna replicate the old mistakes, right? This thing to the left. Oh, you can't see it. But later, obviously, as it happens, we replicated all the mistakes again and again and again. So that's the current state of our code. It turns out that, at least in our hypothetical company, it seems that developers don't read any books. Why is it so? Because if you take a look at their code, their modules, you can see service, repository, impl, manager, the data access objects, etc., right? So apparently, if a developer was supposed to write a book, it would look like this. Chapter 1, characters. Chapter 2, locations. Chapter 3, vehicles, etc. The appendix is the best, like twists, right? So something's wrong with our code base. Of course, all the things I'm showing you, it's not the case with your companies, right? You're doing TDD, high code quality, right? The build is always green. You never push to the broken master. I know this, but it's a hypothetical company, right? So this is our CI system. It's kind of red, but it's not very terrible, because the infra backend plugin report card job didn't fail 5 times in a row. So at least that's good. The most important thing from our CI system is this. So all the jobs take so long to run that we have plugin we need beer that shows us random GIF with a beer, because this is like the last thing we can resort to, waiting for our builds to finish and eventually break. So what's our deployment strategy? Because we have one. It looks like this. So there were like 3 people in the company who understood the whole picture. One of them died, the other is retiring, the third one is sick. So actually right now there's nobody who understands this. I understand only a piece of it here. So the end-to-end tests are here. They take 15 hours to run, and I have to repeat them 3 times for them to pass, obviously. Now, the most important thing, we're agile. We're agile, and we care about code quality, right? Because we have to be agile, right? Everybody's agile. So we have a 6-month sprint, right? It's not the case in your companies, obviously. And the first 5 months is the rear of the horse, apparently. So we do our best. But then the deadline comes, and, you know, stuff happens. So we have a problem. But we're friends here. We can talk about our problems, right? So this is our application architecture. We have some services to the left, insurance service, audit service. And I happen to work in a team that creates the legacy service. It's hard to test the legacy service because of interactions with other services, like customer rental history service, because it talks to the mainframe. It's hard to set this whole thing up on my laptop, especially the mainframe. So it's really tough to test it. All the calls are HTTP. Let's make it simple. I don't know if that's the correct way the pyramid should be standing, but this is how we have it. So I read some articles on the internet about unit tests, but I don't know if I really understood it properly. So in our understanding, unit test means we should have unit number of those tests. So we have 2 unit tests, and we test a lot of getters and setters there. We have a couple of service API layer tests. We have a lot of UI tests, right? Because we want to test stuff. Oh, and one more thing. We have a lot of manual testing. So this is the maximum I can do with like graphical stuff. the idea was that the manual tests are flooding out of the pyramid. There are so many of them. So we have, let's say, a farm of people just clicking around our stuff, because apparently we failed to test it previously. Yeah, speaking of the testing pyramid, who has gone to the presentation of Jakub Nabrdalik? Okay, quite a few people. So it turns out that, let us assume that I've also gone to this presentation, and I have some lessons learned. So let's take a step back and see what this unit test really is. So if we check out the definition, so it's a software testing method where we take, and this is important, either individual units of source code or sets of one or more computer program modules, and we test it. So unit test doesn't mean that you have to test one single class, right? You can take a couple of classes and test them as a whole together. So now you can say, finally, I understood it. I understand unit tests. From now on, I will write unit tests only. And that's a great idea, like this. So apparently, over here, we can see 2 unit tests passing, right? Over here as well, you can, let's say, pull the handle, right? This is my favorite one. So we have the dryer working, the bin working. They don't work together, right? So unit tests are great, but sometimes they're not good enough. So let's take a look at integration tests. So it's a lot of text. In general, we take the unit tested code, we group it in larger aggregates, and we test those aggregates. We can have some in-memory database, some HTTP calls, whatever, right? So now you can say, okay. So I don't need those unit tests because they're useless, because I need integration tests, right? So that's what happens. Actually, this is the real footage of somebody running those 2,000 tests for 70 hours, and the 2 of them are failing. Yeah, unfortunately. It happened to all of us, right? So, yeah, it's slow. It's slow, typically brittle, less brittle than unit tests, more brittle than unit tests, less brittle than end-to-end tests, but it takes a lot of time to run it. And as Jakub said, we need feedback. We need fast feedback from our tests. Now, our beloved end-to-end tests. So we take all the components that we managed to test, we build some sort of executable, we deploy it somewhere, we start databases, brokers, everything, and we test the whole thing. And we come back to this problem. 15 hours, we test every single thing. Typically, we can have a feature that gives us $1 per year, and we run 15 minutes of end-to-end tests to actually test it, right? Pointless. So let's come back to our sad architecture. So customer rental history is extremely unreliable. So this fellow in the middle, why? Because 25 years ago, somebody has managed to create a server somewhere in our company and deployed customer rental history service there. It kind of works. Nobody understands why and how. So all of our tests from the whole company are sending requests to that single instance. Especially people love to run performance tests a lot, right? So we are lucky because 4 out of 5 requests that we send there return 500 because this one instance cannot handle so much load. But this 1 out of 5 works, which is good. So we have a problem, right? We can't rely on this service. So what we did is that we decided to hard code a stub. Right? We said, we're not going to call from legacy service the customer rental history service. We're going to create a stub. We're going to hard code it. It was pretty easy because we had 1,200 lines of JSON. And it's actually kind of difficult to keep that in sync, because let's say we have a source field, and we have to call every now and then the other service asking them, do you still have this source field? Because we're not really sure. Maybe you changed something. Can we check your code? Oh, you don't have the source field. So actually, maybe I should rename it, right, on my side. So it's kind of problematic to keep that in sync. Also, we've decided that we're going to just convert this into a POJO, so we don't need to even test the HTTP connection, which is kind of bad. So now, why is it... By the way, who does stuff like this? Okay, there are some people. Why is it problematic? So let's take a look at the test and the reality. So we have the legacy app, and the legacy app, let us assume even that the legacy app decided to write a stub with a fake HTTP server, so a real request will be sent. So the thing is that the legacy app says, defines how the stub should behave. right? So if the legacy app says, if I send you a GET request to the foo endpoint, please respond with OK. So if I actually do it, I'm going to have unicorns. It's going to pass because I told it to behave like this. But in reality, there might be no such endpoint. If I don't keep that in sync properly, it might break. So actually, this test to the left is completely useless. But I'd say that most people do it like this. So how can we create reliable stubs for services we don't control? This is often the case. For example, we have some external API that we're calling and it's very brittle, or there's another team that doesn't care about code quality and we have to somehow stub it out. There is a way. We can proxy the calls. So let us assume that the customer rental history service has 5 GET endpoints. Let's keep it simple. What we can do is write 5 tests that instead of calling the customer rental history service directly, will call the proxy, and then the proxy will call the customer rental history service. Why? Because the proxy can, let's say, can record the pair of request-response, right? What you sent and what you got. And the proxy can convert it into a stub definition. You can dump it into some sort of an artifact and upload it for other teams to use. So instead of doing it manually, we can record the real traffic and store it in the form of a stub. So that's a good technique to create, quite reliable stubs. This is an example of a stub. Let's say that we have a request section. Actually, this is a stub that was created from calling an API of a tool called Stripe. So I called Stripe on the URL v1 charges with limit 25 with the method get, and I got back a gigantic response with 10,000 lines of JSON, and it got stored in this form of a stub definition, right? Given this request, send back this response. So now, let's say that we did that. We're running those tests every hour, 5 minutes, every day. What can we do with those stubs? How can we test the system? So that way, if we run the integration test of the legacy service, we can fetch the stubs that were created from the proxy, start a fake HTTP server, and feed it with stubs. No longer do we write it. It comes from the proxy. So the outcome is that we have fast feedback from quite reliable stubs. Why quite? Because if we, for example, create those stubs every day, something could have changed in the meantime, right? And the key thing is that we spend less money on end-to-end tests. Why? Because if we fail those tests, so we can't communicate, for sure we're going to fail the end-to-end tests. Good. So we know how to deal with the apps that we don't control. How about those that we do control? So there are some hard problems that we have to tackle. How can we add something to a service without breaking the client? That's kind of trivial. But how can we, let's say, remove something from the service, from the API, without breaking the client? Or how can we modify it? So in one of the companies I was working for, we had this approach called the Boy Scout rule, right? Whenever you go to the code, like a Boy Scout, you fix some small stuff, you refactor a little bit of code to make life better and to have world peace. So one of those junior developers decided that it's time to fix the world. The problem was that the junior developer has seen a typo in the API, right? So the junior developer fixed the typo, fixed the tests, and we went to production. And then we had a problem, because none of our clients fixed the typo on their side, right? So we need to have some sort of a mechanism that will catch those sort of exceptions. Another thing, how can a service developer know how the clients are using the service? We often don't know or care, but it's kind of useful information. How can we enable short release cycles? Because we'd like to do continuous delivery. 6 months is good, but let's make it a week maybe, or a day. That's, let's say, better, I guess. So how can we do it? And, as everything in the IT industry, if you think that I'm talking about something relatively new, you're obviously wrong. So we have something called service evolution patterns, and I guess you know quite a few of those. We have something called a tolerant reader, right? So let us assume I send you a request with 500 fields, but you care only about one. So maybe you should ignore the unknown content, accept what you understand, and not throw an exception, right? This is a tolerant reader. Schema versioning, right? V1, V2 in the URL headers, different approaches. Extension points, that's a beauty. So we have an optional map of something to something that can always change, has meaningless names, and you have to ask the provider of the API to give you a gigantic manual to understand what does the field EX2089 mean. Then you check out the manual, oh, it's the username, right? Extension points. And now, consumer-driven contracts. Ian Robinson wrote an article about this on Martin Fowler's blog 10 years ago, so yeah, fresh stuff. And I'm pretty sure that if I did some sort of a research in some mathematical white papers from the 50s, for sure somebody wrote about this there. So before we go any further, let's define some terms. Producer. What is a producer? Who is a producer? It's a service that exposes an API. So we have a controller, for example, right? Or sends a message to a broker. That's a producer. Consumer. It's a service that consumes the API of the producer, so sends a request, or listens to a message from the broker. Contract. Contract is an agreement between the producer and the consumer on how the API message will look like. It is not a schema. We don't care about all the request fields and all the response fields. What we care about is a pair. For this request, such a response. For that request, such a response. We care about usage scenarios, so to say. And now we have different types of contracts. We have provider contract approach, meaning, let's say we have a service and two clients, and let's say we have a public API. So we don't really know who's using our API. There are too many users. So we say, okay, if you send us those, let's say, such a request, we will respond with those 3 fields in the response. So from the client perspective, it's like, okay, so that service responds with those 3 fields. Fair enough, I need only 2, but okay, I understand I'm going to get 3. Right? So that's the provider contract. The world looks like, let's say we're looking at the world from the point of view of the provider. Now, consumer contract. It's a little bit different. So let us assume that we start from the perspective of the client. And the client A says, if I send that request, I would like to have the field A and B, like in the response. That's what I care about. Nothing else. Client B says, if I send that request, what I care about is the field C. Nothing else really matters. So from the service perspective, it's like, okay, the client A needs 2, client B needs the 3rd one. So in reality, I will send back 3, but from the client perspective, they don't even know about the existence of the 3rd one or the 2 first ones, right? So it's a different perspective. And now, consumer-driven contracts. What is this mythical thing? It's an approach, basically. So consumers define their contract saying, consumer A says, I need those 2 fields, right? Consumer B says, I need that 3rd field. And they send those requirements, those expectations, in a form of a, let's say, executable test, right? So consumer A says, I need those 2 fields in the response. There you go, this is a test, dear producer. Test if you actually do that, right? So there is a conversation going on between the consumer and the provider. Consumers send the requirements, and then the provider can assert whether those requirements are met. This is the main concept. So it's an approach. And of course, there are, let's say, there's some tooling around it, but in general, it's an approach. So what are the benefits of such an approach? Like the consumers drive the change of the API. Because we can align the, let's say, the service providers with business goals of the consumers. Why? Because the consumer will change the API when it needs to, when the business, let's say, requires it to happen. From the service perspective, services know exactly how the consumers use their API. So client A needs only 2 fields, right? Client A needs 2 fields. Client B needs only 1 field, right? We know how it's done. So maybe we should talk to client B and say, maybe you should use one of those 2 fields, and then we can remove the 3rd one, right? It's easier for us. So we have an insight about how the API should be used. And we can evolve services easier because we can reduce the number of coordination. Because we have some automated solution to test if both parties are compatible with the contract. So we can reduce the amount of coordination if we want to evolve the interface. And contract tests really help in configuration of continuous delivery pipelines, because you can in a quick way, fail fast. On your laptop or in the build pipeline, you can fail extremely fast if you cannot talk to other clients or you broke, let's say, your compatibility of your API. So this is our sad situation, and we would like to go back, let's say, to the proper one. So we would like to have a lot of unit tests, some service API, and some contract tests, right? The key thing to remember is the contract tests should not replicate business, let's say, solutions, so to speak. So if functionalities. So if, let's say, we have an endpoint that verifies if somebody is a fraud, and we can have two outcomes. Somebody is a fraud or not. But somebody can be a fraud in 250 different ways. Most likely we'll create two contracts, because there's no necessity to test all 200 combinations. Either you are one from the integration perspective, or you're not. End-to-end test, UI test, just a little bit of those. So if, let's say, our service has 10 very, very important features, right? I assume that if at all, we would have those 10 features tested via, let's say, end-to-end or UI tests, right? Let's say we have 100 features, 10 of them are important. And manual tests, we can have those if something is too expensive to automate, or it's so critical, maybe from those 10, 5 are so critical that if they are not tested, our company goes bankrupt. So maybe we can consider doing manual testing of those. We're at a conference, right? So microservices has had to appear. So, you know, let's come back to the situation that I'm a developer at the company. I went to a conference. I heard that I have to, to solve all my problems, I have to migrate to microservices, right? That's what I heard. Fair enough. I mean, what can go wrong? So let's do it. So we decided to migrate to microservices. So what is the problem? We're in the process of doing so. We extracted some bounded context. We have some services flying around. But we're still in the process of migrating. So our monolith is a source of truth. It contains all the data, or most of the data, right? So apps are calling the monolith to get some data that we haven't managed yet to extract. And from the monolith's perspective, we don't really know if we can change the API, because we have no idea who's using us, how they are using us, no idea. So this is our situation. We have 6 services. All of them are calling the legacy service to fetch some data. And of course, everybody does it in the same way. So in order to stub the user endpoint from the legacy service, everybody creates the same stub, right? Rings a bell? It's typically the case. Now, what is the problem with this approach? Exactly the same one we had at the beginning. If the consumers are writing the stub, it's unreliable, because the endpoint could have changed in the meantime. We don't know how often they sync. And we waste a lot of time on writing the same stub all over again. So if 10 more services pop up, again, they have to write the same stub. Insane, right? So let's try to solve this problem somehow. So we're going to try to invent some sort of framework to do contract testing. Why not? So to begin with, we need to define a contract. So you can choose some sort of a DSL, some sort of a language. Let's say we want to be Polyglot. So now everybody is using YAML, right? We love YAML. We love the missing white spaces, moved tabs, right? So let's pick YAML. So we define a contract, agreement on how the API should look like let's say, in the sense of communication, a single scenario. So given this request, so if we send the post method to URL check with body containing, let's say, JSON with a field age equal to 10, if that happens, we would like to send back this response. Sorry. So status to 100, some JSON like state is not OK, and content type application JSON, right? Given this request, send back this response. Fair enough. Are we done? Not really. We could have typed it in some wiki page, email, or whatever, and it will be the same. So what do we need to do now? If we have a contract, we need to assert whether it's actually met, right? If it's valid. So we need to see if the producer of the API actually has such an endpoint and returns such data. Okay. So that's the first thing. We need to assert whether the producer, let's say, meets the requirements of the contract. The second thing we want to assert is, or we want to do, is to build some reliable stubs. Fair enough. So we want to have some contract tests of our legacy service in order to build the stubs. So from the DSL, from the YAML, what we could do is we could generate some tests, right? How can we do it? So we have the YAML. When we build the project, some sort of a building mechanism could analyze, read the contract definition, generate and run some tests to verify if actually there is such an endpoint and return such data. And we could generate some stubs. So this is an example of a Java-generated test. Let's imagine that we have such a thing. Let's just focus on the following thing. We have a request, h20 content type application JSON. We send the post method to the URL check. And we want to verify if the response is correct. So if the response from the producer actually returns what was expected in the contract. If that's not the case, we will break the build. Why? Because it means that the producer is not keeping its promise, which was defined in the contract, right? And this is the generated stub, meaning if you send the URL if you send a request to the URL check with a method post content type application JSON, let's say, so given this request, we send back this response, right? Status to 100 and body contains status OK. And it's an application JSON, right? So we did two things. We generated tests and we generated the stubs. So the better approach would be as follows. Let's say we have somewhere a stub storage, whatever that is. So the monolith contains the contract definitions. We generate a test to verify if it's keeping its promise. We're generating stubs that we are uploading to the stub storage. And then all the services can fetch the stub. So we invert it. The services, the clients, do not write the stubs. The stubs come from a producer that was verified that actually keeps its promise. So how can we use those stubs on the consumer side? So we have some consumer tests. So clients are trying to verify if they can call the API of the other app. So some testing framework, some testing solution would fetch those stubs, right? Start some in-memory HTTP servers that would be fed with those stubs. And when the tests are executed, they are calling that stubbed HTTP server. And the key thing to remember is that the stubs come from the tested producer. So we can trust them. So what is the outcome? We have fast feedback from reliable stubs. Why not? Why they are not quite reliable? They are reliable because the moment the producer has changed, new stubs get uploaded. So the next time the consumer is built, if there is a breaking change, the consumer will fail. We spend less money on end-to-end tests because if the clients are not compliant with the stubs or the producer broke its compatibility, the pipeline will break at the beginning or even on the, let's say, our developer's machine. And we don't waste time on duplicating stubs. That's also very important. Okay, so now what about those new shiny microservices? So let's say that we have a new team assembled and we're going to write a microservice. So the key thing to remember about this case is we often don't care about the quality of the API that we're producing, right? Specifically, teams that create the UI are extremely unhappy with the amount of effort they have to, put in order to create that request that fits the requirements of the producer, not the consumer, right? That's what typically happens. And believe it or not, but the consumer is called a consumer because it consumes the API, right? So it kind of knows how to send that request, right? So just for a second, imagine the situation where the consumers actually take part in the creation of the API of the producer. I know that it sounds crazy, right? Because typically the producers say, this is my API, you don't like it, don't use it, write your own, right? So now let's imagine that we have a conversation and cooperation and we create an API that actually is usable. So the producer's API change should be driven by requirements of consumers, right? And now consumer-driven contracts. How can we do it? Let us imagine that we have the team called consumer, and the consumer is supposed to send a request to some other service. Let's call it a producer, right? The thing is that we are agile, and the producer team will be assembled in 3 weeks, right? So we have a couple of options, like do nothing for 3 weeks. I mean, okay, most likely we're going to get fired, but it's an option. Another thing is we can write some sort of a stub in whatever language we know. The problem with that is that the producer team, like the moment the producer team is created, maybe they're going to pick a different language, so our stub is like, we can just throw it out because, yeah, it's like completely useless. So what can we do about it? Let us assume that we have such a situation that the contract definition for the whole company lay in a Git repository somewhere. Right? So now a consumer says, okay, let me play around with the contract definition of the producer that doesn't exist, right? I'm just going to invent, like simulate that it's there. So this is a YAML that represents the contract I would like the producer to meet. And now in the repo with contracts, under the folder representing the producer, I put the YAML there, right? So I interact with the repo saying, I guess this is the contract I would like the producer to meet. So the key thing to remember, again, is that the producer doesn't exist at all. Like, there's no code, no team, nothing. So what we can do from the consumer perspective, so I'm a consumer, I have my laptop, I put the YAML there in the repo. I can locally convert the contract to a stub and install it in some local stub storage. Right? Some M2 maybe, if it's Maven artifact. So I convert the YAML into a stub locally. And actually, I can run and write my consumer tests and start the fake HTTP servers from my local M2. So I can send real requests to a real HTTP server that simulates a real producer. And I can do it in a very fast way because I can convert my contract into a stub definition extremely fast. So it kind of resembles like TDD on the level of architecture. So what's the point of TDD? Right? Red, green refactor. So first I wrote, let's say, a consumer test that sends a request and expects some response, right? I got red. There is nothing running, right? Connection refused. The next thing I did was I created a contract. It was converted to a stub. I ran the stub locally. Now I have green, right? Because the stub represents what I would like the producer to respond with, and my test pass. And now what I can do is I can do refactor, saying, do I really like this API? Maybe I'm going to change it, right? So let us assume that I'm going to rename a field. And I iterate again. Now, in reality, what often happens is that you have to file tickets, ask the producer team, can you please actually create some sort of a stub that we can use? You play around with it. Of course, you have to wait. You play around with it. And then after some time, you say, I don't like this API. So you have to file another ticket. Like, can you rename the field? And then again and again. And here, you do it offline without the producer existing, right? So you run the tests, and you're happy with the outcome, right? So you file a pull request saying, yeah, I like it. This API is good. I'm filing a pull request. So not 3, but 5 weeks have passed, and the producer team is assembled and says, okay, I'm ready to roll. Let's see what we have there in the repo with contracts. Oh, there is a requirement that I have some sort of an API. Okay, that's interesting. And now if we scroll back a couple of slides, we had the slide saying, from the contract, we generate stubs, right? Like we did like a second ago. And what was the other thing? The tests, right? So I run the build, the tests are generated, the build fails. Why? Because I have no code, right? I just started my project. But I already have a test that verifies whether I am compliant with the contract. So what I have to do is just implement the missing controller, the missing, let's say, implementation. And once I've managed to make the generated test pass, I can merge the pull request, right? Both the one in the repo of contracts and my implementation. So now we have the producer, we merged the code, we merged the missing implementation, and we have some sort of a CI system. So when the producer app is built, two things are uploaded. Obviously the binary, some sort of executable, right? It's sent to some sort of a binary storage, and the second thing that gets uploaded are the stubs, right? So we package the contract definitions, we package the stubs, and we upload them to some stub storage. And how can the consumer actually use those uploaded stubs? Consumer has, let's say, the consumer tests, and it says, okay, I no longer want to use my local stub storage. Please fetch the stubs from the external stub storage. So the moment the producer passed the builds, the stubs were created, they were uploaded, the consumer can fetch those, right? So if the producer has actually managed to properly make the test pass, I have a guarantee that those tests will pass because I have already tested them when I build the stubs locally myself, right? That way, we have managed to verify, like what we have managed to do is first, create the API that suits the consumer needs, right? Also, we've managed to verify that on production, we will be able to communicate. We will not fail due to invalid integrations, right? There's not going to be any missing field, invalid field, 404 or stuff like that. Yeah. Now, I said that all contracts are stored in a single repo. Yes, I did say that. So what you can say, can I actually create living documentation out of it? Because we have contract definitions, so we have usage use cases, right? Yes, so what you can do is you actually can scan all the YAMLs, let's say all the contract definitions, and convert them into a documentation. Because all of you, of course, love writing documentation and supporting it, maintaining it. What if we don't have to do it? What if it comes from the contract definitions? Now, I mentioned something about a predefined structure in the repository of contracts. So let us assume that, let's say, the structure looks like this, that we have the producer folder, and under the producer, every single consumer has its own folder, right? Because the idea of consumer-driven contracts is that every consumer has its own definitions, like I need those fields. And for the same endpoint, some other consumer needs other fields. So if we have, let's say, folders in that structure, can we sketch a graph of dependencies? Actually, we can, because we know who the producer is and who the consumer is. And if that consumer is actually also a producer for somebody else, we can sketch the graph of dependencies. And that's how it would look like. So there is, like, to the left, the predefined structure. Let's focus on the graph. So in the middle, it doesn't work. In the middle, you can see Beer API producer external in version 2.0 is used by bar service that is used by yet another consumer. And all of that comes out of the box if you follow conventions, right? Because in the folder of the Beer API producer external, there was a folder for bar service. And for in the folder for bar service producer, there was a folder yet another consumer, right? So you get it for free. What about messaging? So, we tend to use messaging. We think we can test it. So we typically, what we do is we create a fake, let's say a fake POJO. So we create a POJO for a fake message that we're going to send in our tests. We send it to some topic, whatever, like in memory one, for sure. And then our own app takes the message, and, it's great. But what typically happens with the testing frameworks for messaging is the following. Often, we do not even test, or they don't test, the name of the topic. There is some sort of an in-memory, queue or whatever, and the message is just passed. So this is what happened in one of the companies I work for, that we send a message to one topic, and we were listening to another one. The feature was working, but there were no messages. Another problem that typically happens is that even if the topic is correct, sometimes testing frameworks do not test serialization. So what happens is they take your POJO, they put the POJO in an object, like the object, to the queue, and then your listening component just takes the object. So in your test, it passes. On production, it doesn't. Another problem is that typically the payload that you're using, the definition of the payload, is the same class you use in the component used for receiving the message. So if you have a typo on the sending side, you have the same typo on the receiving side. So you'll only see that on production as well. So for messaging, we have another YAML saying on the producer side, do I even trigger the message? Is the message sent to a proper destination? And can I deserialize the message properly, right? Meaning we have a body definition, and let's say we don't attach it to any pojo or any let's say class definition at this point, because it's just a definition of the message, right, of the message payload. So it's on your side as a, let's say, framework let's say as a developer to properly let's say analyze whether the deserialization took place, because we at the point of defining the body do not assume that you're using Java or any other language, right? So on the consumer side, you can verify, do I listen to the proper destination? Because maybe I'm listening to foo and you're sending to bar, right? And can I deserialize it properly? So we have two ways of verifying that. Now what about polyglot support? Let's say that we have a NodeJS application sending a request to some other service, right? An HTTP request is sent. So let's say that I wrote some pathetic Node.js app because I don't know Node.js at all. And what I wanted to achieve is that I'm going to have some sort of connection refused or something because the app is not running. But for some reason, as always with JavaScript, I ended up with undefined. So that's the best I can do. So how can we solve this problem with the polyglot support? Let's say that we have the non-JVM app, and we would like to fetch the stub of, for example, a Java app. How can we do it? Conference, right? Docker had to be here. Finally, we have Docker at the end. So we have a container. That container, if we tell it to do so, like let's say Node.js developer says, I would like to fetch the stubs of the Java app. So the Docker container says, OK, no problem. I'm going to fetch it to you from the stub storage. And there you go. It's running at the port 1234, right? And now the Node.js app can send a request to the port 1234, and it's going to get the response from the stub, right? So we can, for example, do it like this. And then we send, again, the request, and we get the information from the stub. Now, can I generate tests for any app in any language? Because Java for Node.js, no way. I mean, Node.js developer will never install Java on their machines, right? No way. So, again, let's do it like this. Let's say that the Node.js developer creates contract definitions in YAML, 2 endpoints, Docker. So what we're doing is we're running the app. We're attaching, like mounting the volume with contracts to the Docker instance, to the Docker container. Inside the Docker container, we generate tests that send requests from the container to your app. And once you're done, the Docker container will generate stubs and send the stubs to stub storage. So you don't even see how it's done, and you don't care really. Okay, so that was it from my side. So there's going to be time for questions. I'm going to show you this slide because what we managed to build is the Spring Cloud Contract Framework. So as you could have seen, I haven't mentioned Spring at all throughout the presentation. The framework used for stub definitions, the JSON, is called WireMock. So it's a well-known framework to stub HTTP calls. In Spring Cloud Contract, we have DSLs that you can use, that you can define using Groovy, YAML, or Pact. We support messaging, frameworks out of the box like Spring Cloud Stream, Integration, AMQP, and actually whatever you want, because we have an abstraction over like whatever you have. You just have to tell us how to send and how to receive stuff. We can resolve dynamic pieces because, for example, in your contract you can have a date, and you don't want to fix the date in your tests. So you can say any date or something like this. You can reference, for example, requests from response. You can do quite a lot of advanced stuff. You don't have to, like I mentioned, the stub storage. The stub storage can be Nexus, Artifactory, but it can also be Git. You can push stuff to Git. Or Pact Broker. And there is much, much more, so you can read the docs under Cloud Spring IO Spring Cloud Contract. And I guess we have 5 minutes for questions. There you go. The question is, do you have support of SOAP? We do not completely. There is a way to do it. We have an issue to start supporting properly XML, because currently we support only JSON. There's an open issue for that, and we're planning to do it for 2.1 release. The question is how it relates to Pact. So Spring Cloud contract. So maybe let's take a step back for those who don't know what Pact is. Pact is another framework used for contract tests. The main difference between Pact and Spring Cloud contract is that Pact is supports the consumer contract approach first, meaning every single consumer has to write a test manually describing how they would like the producer's API to look like. So if there are 10 different consumers that use the producer in the same way, they have to write the same test 10 times. Another problem is that if there is an 11th consumer, and the 11th consumer creates a test describing the usage of the API in such a way that the producer gets broken, it's going to get broken immediately, right? Because the stub is going to be uploaded to Pact broker, and the producer is going to fetch the contract definitions from Pact broker, and it's going to fail. From our perspective, it's something that we prefer not to do. So we shift it, meaning either the contracts lay with the producer, or at least the producer has to approve a pull request in order not to break immediately, but have some sort of security check. Another thing is that we wanted to reuse from the very beginning all the infrastructure we already have. So we didn't want to write a broker or something. So we reuse Git, we reuse Nexus, we reuse the infrastructure you have. But Spring Cloud Contract understands Pact. So it can generate tests from Pact files, it can generate stubs from Pact files, so it can perfectly work with Pact. There you go.
There was a quite assumption about the producer's view that they are stateless, because in a lot of cases you actually have to bring the producer or the service to a particular state before you want to execute a test case. So have you come across cases like that and how to solve it?
So the question was about the state, because I've shown stateless situations. What about stateful? There are two answers to this question. The first one is we support stateful stubs, which I don't like. So this is we're coming to the second thing. In my opinion, contract tests. So I've shown you the generated test. I don't want to go into details, so now is the time to do it, actually. The generated test extends a base class. In the base class, you can do the following. This is my controller. The controller uses a service. I'm going to mock the service and return fake data. And this is how you should do it. So I don't want to go to the database. That's the essence of it's a contract test, in my opinion. But there are some people who treat contract tests also as functional tests. I think if it brings them money, do it. I think that at a certain point, it can increase the complexity a lot. But if it's managing, it's a proper thing for them, then why not? And then they have the problem with stateful stuff, right? Because they have to set up the database, etc. Another thing is that in the contracts, if you name the contracts in a proper way with a prefix, with a number, we will know that it's a stateful scenario. And for example, if you're going to create 3 contracts with a get call to a single endpoint, the first time you're going to get the response from the first contract, then from the second, and from the third, right? Like this. So we can do it. Any more questions? So there are no more questions. Let's all head for lunch. Thank you.